Welcome back, everybody, to a fun-filled day at I Am Math. Good morning, good afternoon, and good evening. We're going to continue our adventure on radicals with radicals part 3. Be sure to check out my previous videos on radicals part 1 and 2. Today we're going to be doing slightly more complicated things, but make sure you look at radicals part 1 and 2. And if you're good with that information, you'll be good with this information. Let us continue our treatment then with radicals, and let us consider n root of a to the power of b. This can be rewritten as a to the b over n. For example, if I look at the square root of a, we can think of this as an index 2 and a raised to the first power. So this is a to the 1/2. Or if we have index 2, x to the power of 1, this is just x to the 1/2. Or if I look at the cubed root of x squared, we can rewrite this as x to 2/3. Similarly, if we have the fifth root of x cubed, we can rewrite this as x to the 3/5. Now suppose we have something like this, the nth root of a multiplied by b. So we have a product rule for radicals. When we encounter something like this, we can say that this is equal to the nth root of a multiplied by the nth root of b. And we can say that if n is even, example 2, 4, 6, etc., then a and b must be greater than or equal to 0. If n is odd, example 1, 3, 5, etc., then a and b are valid for all real numbers. So for example, if I have the square root of -4, since the index is 2, where n is even, then we say that this is not valid, since a, which equals -4, is less than 0. However, if the index is odd, then this is permissible, because this is just -4 to the 1/3. Let us suppose I have a question to simplify the square root of 40. Given our product rule for radicals, we can say that this is simply 4 times 10, or the square root of 4 multiplied by the square root of 10. The square root of 4 is just 2. So therefore, square root of 40 is just 2 square root of 10. Something to remember is that if we have a to the power of x multiplied by a to the power of y, we can rewrite this as ax plus y. So for example, if I had 2 cubed times 2 to the 5th, this is just 2 to the 8th, because we can have 2, 3 plus 5, which is just 2 to the 8th. This only works if the base is the same. Let us look at a more complicated problem. If we were asked to, for example, simplify the square root of 16 multiplied by x to the 4th multiplied by y to the 8th. we can rewrite this as the square root of 16 multiplied by the square root of x to the fourth y to the eighth. The square root of 16 is simply 4 multiplied by x to the fourth y to the eighth. Or this is just 4 multiplied by x to the fourth y to the eighth to the power of 1/2. Or this is 4 multiplied by x to the fourth. We can distribute the power to 4 and then to 8. 4 to the 1/2 multiplied by y to the eighth multiplied by 1/2. So we have 4 times x. 4 divided by 2 is 2. And then 8 divided by 2 is 4. Therefore, our answer is 4x squared y to the fourth. Remember, when we take the square root of some number, we can have a plus and minus. Therefore, we need to consider that. But since x squared y to the fourth is an even power, so it'll always produce a positive number, we don't have to worry about the absolute values in this case. Suppose we had something a little bit more complicated. Like this example, the cubed root of 64 multiplied by x to the power of 9 multiplied by y to the power of 10 multiplied by z to the power of 5. We can rewrite this as the cubed root of 4 cubed multiplied by x cubed cubed multiplied by y cubed cubed will give us y cubed cubed will give us y to the 9, but we still have one y left over to give us y to the 10 multiplied by z cubed times z squared. We can rewrite this as 4 cubed multiplied by x cubed cubed multiplied by y cubed cubed multiplied by y multiplied by z cubed times z squared, all raised to the power of 1/3. Now 4 cubed to the power of 1/3 is 4 multiplied by x cubed to the power of 3 raised to the power of 1/3 is just x cubed. Similarly, y cubed raised to the power of 3 raised to the power of 1/3 is just y cubed. And then we have y to the 1/3. Z cubed to the power of 1/3 is just z. And then z squared to the power of 1/3 is z raised to the power of 2/3. Let me just write on the side here, y cubed raised to the cube power, and then this is raised to the 1/3 is just y cubed cubed multiplied by 1/3, which is just y cubed. Continuing, we have 4 multiplied by x cubed. Now we have y 3 plus 1/3 multiplied by z 1 plus 2/3, which is 4 multiplied by x cubed multiplied by, now 3 plus 1/3 is 10/3, and then 1 plus 2/3 is just 5/3. This in radical notation, we have 4 times x cubed multiplied by the cubed root of y to the power of 10 multiplied by the cubed root of z raised to the 5th power. Or we can rewrite this as 4 times x cubed multiplied by the cubed root of y to the 10th power multiplied by z to the 5th power. So there's a couple ways of doing this. Let us look at another problem. If I had the 4th root of x to the 4th multiplied by y to the 12th. We can rewrite this as x to the 4th multiplied by y to the 12th to the power of 1 over 4. Or x to the 4th raised to the power of 1/4 multiplied by y to the 12th raised to the power of 1/4, which is just x multiplied by y. 12 over 4 is 3. However, since our index equals 4, and that's even, and our powers here are 3 and 1, and those are odd, we have to consider the absolute value. Therefore, we can say that the 4th power of x to the 4th multiplied by y to the 12th is x times y cubed. This brings us to the end of Radicals Part 3. I hope you enjoyed the lesson. I look forward to seeing you again. Please click like, subscribe, comment below.